The next presentation is of Dr. Roberto Germano from the Oxhy company. Maybe I'm wrong.
Oxhy.
Okay, thank you. I'm sorry. Okay. Properties of liquid water, the quantum origins. Please.
Okay, thank you very much for the invitation to the organizer. And okay, this is not about quantum computation, but it is about energy extraction, something similar to a photovoltaic cell based on a new effect. So this is the very simple system that we made many years ago and we patented before publishing. It is a very simple cell with pure water on the left, pure water on the right, a platinum electrode on the left, a similar twin platinum electrode on the right, and we have an electrical load. And so normally everybody knows, also children knows that nothing is happening. But when you create an asymmetry, physical asymmetry, not chemical, in one half of the cell, you obtain a current. How this is possible? This is possible because there is a new effect based on the quantum nature of liquid water. I will do fast because we are late. So what is the theoretical explanation of this? The origin of the experiment that every children should say that is stupid is was coming in my mind from the QED description of liquid water. The QED description of liquid water is not disorganized ensemble of molecules, but something more and more complex. Every liquid is a matrix of non-coherent molecules or atoms, and there are also many coherence domains, in the case of water about 0.1 micrometer in size, in which all water molecules are oscillating in phase with a self-trapped electromagnetic field. So, what does it mean? This, in particular, in the seminal works of Giuliano Preparata and Emilio del Giudice and Giuseppe Vitello, that is also our consultant in our company. This is what is important to understand. It is important that in a liquid, the molecules are in this kind of organization. So there is a matrix that is exactly how we imagine and we study it is a liquid that is like something like a dense gas. But there are also the coherence domains. Why this conclusion of the calculation of coherent QED is very important in the case of liquid water? Because this is very important because this is describing for the first time the transition from gas to liquid from quantum point of view. But in the case I forgot this music. In the case of the water, this is very important because we have this kind of situation that it's better to see in this slide. We have that the excited state, we know that the liquid water molecules is, from a classical point of view, it is a perfect insulator because to ionize a molecule that has an energy of ionization energy of 12.6 electron volt means to use X-ray, means to use thousands of degrees of temperature. But in this case, what is the important thing? Is that the second level in the coherence domain is very near to the ionization level. So we need only 0.5 electron volt to extract the electrons. This is why we are able to extract the electrons. And this is obviously this is changing thanks to temperature. So we have, if we are able to do this kind of asymmetry in the system, it is something similar to a photovoltaic cell with silicon, but not in the range of visible light, but in the range of the infrared spectrum. After the patent we published, and the basis of this phenomenon that was from the reason why I was doing this experiment, it is also described in this Italian book with many interesting papers published. In the recent years, many international scientists are beginning to speak about this new phenomenon from many points. And also, there are also many international papers that are speaking about the domains in aqueous solution. So it is very simple to go deeply in this new phenomena. This is a few international papers of mine, in particular together Vittorio Elia, and these are the paper about these topics of Giuseppe Vitiello, theoretical physicist of Salerno University. These are other papers published by Antonella De Nino and Luca Gamberale. And let's remember that also in the case, everybody I think you know, this is the first transistor, was beginning with a very simple system, macroscopic, not microscopic, but macroscopic. And this is very important to remember this. So we recently, 1.5 years, we made a startup. And in this startup, we are going toward the technological application. We have now 1 microwatt for cell, but this means that if we are able to, like we are beginning to go in this direction, to have a cell of 1 millimeter, nothing so microscopic, we are able to have 1 kilowatt for cubic meter of power density. It is a lot. So now we are in this direction, we are going in the direction of miniaturization. And this is the nowadays situation of the power density that is very impressive. So also this is the demonstrator that some of you were able to see at the desk. And this is the Oxy team, the senior Oxy team, in particular the scientific advisor, probably you know, is the Giuseppe Vitiello, theoretical physicist of Salerno University. And Francesco Paolo Tucinardi and Graziano Terenzi are the principal associated. This is the very young Oxy team that we were able to construct. We already reached 1 million of pre-seed funds, and now we are in the second phase of the pre-seed how do you say, the president, yes, exactly. And it is 3.5 million. We are also in a good situation. That we are here if you want to visit us, and these are my personal contact. Thank you very much.
Thank you very much for your not trivial presentation. Thank you. Please comments and questions.
It is late.
No, maybe my question maybe I don't understand. My question is a very nice presentation in the field of the quantum technologies.
Yes.
How
not computation.
Quantum technology. Can you comment if your research can be in your research the quantum computing should be useful? How?
Not a computer. It is a quantum energy technology. It is quantum energy phenomenon, similar to photovoltaic cell, but in the range of the infrared. So this is very interesting because this means that you have a photovoltaic cell that is working in the darkness. So this is a very interesting phenomenon that probably is very correlated to also the way of working of biology. Because, for example,
another approach.
Yes. For example, the Nobel Prize Saint Georgi who received the Nobel Prize for example, ATP phenomenon and the so-called Krebs cycle. Okay, he received the Nobel Prize because he was able to understand all the steps of these biochemical reactions. But in this biochemical reaction, many electrons were needed. And he said in the 60s, in the 50s, he said, I was understanding all the cycle, but from where are coming all these electrons? It is a mystery. Now we are beginning to understand how it is possible that liquid water, that theoretically from the classical point of view, it is a perfect insulator.
Yes.
On the contrary, is able to give a lot of electrons. Why? This is the phenomenon.
Another question: did you think about liquid helium, for example?
Sorry?
About liquid helium.
Ah, yes.
Because also liquid helium perfect insulator, super perfect insulator.
In effect, it's very similar phenomenon. But this is true. This kind of approach is true for every transition from gas to liquid. In particular, in the liquid water, we have this gap, the energetic gap, that is able to explain why we have so many electrons, almost free electrons, in such a way that the liquid water may be described as something similar to a semiconductor, not insulator. This is a new kind of vision.
Thank you very much.
Thank you.
Very interesting
Thank you.
talk. Thank you.